Okay, the last thing we'll talk about is the gimbal lock. Okay, why nobody uses Euler angles? I just think it's a great way to show rotations, but when you want to use it numerically, you don't really want to use them because of this phenomenon called the gimbal lock. Okay, so what happens is there is a certain configuration where you lose the ability of Euler angles to represent rotations. Okay, so the definition of a gimbal lock is that gimbal lock is the loss of a degree of freedom. Okay, so this happens when two axes are parallel to each other. Okay, so I will show you the visually what happens first, and then I'll show you mathematically what happens. Okay, now this is, you should remember that this is not a real phenomenon in the sense that in reality there's no lock, but the choice of Euler angles leads to the lock. So this happens due to the use of Euler angles. Okay? There are other methods which you can use which will not lead to the gimbal lock. So it's a representation issue. Imagine a language which cannot describe certain words. So that's the problem with the language, not that the object which you're trying to describe doesn't exist. That's what it is. I think the best illustration of this is actually looking at the Wikipedia page. There is like a good animation which we can look, and then I can explain based on that. So gimbal lock wiki. Okay, so that one is hard to understand. It moves so fast, but there's another one down here. This is easy to understand, I think. So those three rings are basically three axes about which you can rotate. So for example, I think the interpretation here is that if you rotate about the red, it's going to be rotated about x-axis. Green would be y-axis, and blue would be z-axis. Okay, so if you now take the green, okay, the y-axis, and you first spin it by 90 degrees. So when you spin it about 90 degrees, you're taking this and you're turning this about this axis. So when you turn that, what happens is the green lines up with the blue. Okay, and once those two axes become parallel, it turns out that you can no longer represent a rotation about the blue or the green because those axes are parallel, right? It's like x, y. So when you have x, y, x, you can, that represents a rotation, but if it becomes like y, y, x, and so you cannot really represent rotation. So I think that that is one way of understanding the gimbal lock. That is, when two axes are parallel, which is effectively saying that instead of having three angles x, y, x, you're using x, 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 y, which is not going to represent 3D motions because now they were locked. Now, this I think is not very intuitive to some people, so I'll show you mathematically what this really means. So this is using the 1, 2, 3 Euler angles, which is the one we use, and I'll show you what happens if you take the three rotations. So we have discussed using phi, theta, psi. Theta, and then psi. So let's do this thing. Just like what we saw in that figure, let's just put theta equals pi divided by 2, or 90 degrees, right? It was turned by 90 degrees. So if you do the math on this, that is put ry equals pi divided by 2, and run it through the code, you will get this formula. 0 sine phi plus psi minus cosine psi plus phi. 0. Yeah, so that's what you get. Now let's see. So this is a configuration. Now we want to be able to still represent any orientation, so any combinations of phi and psi. So what happens if you put phi equals 0, psi equals pi divided by 2? Okay, so you'll end up with 0 sine of pi divided by 2 is 1, minus, so cosine phi divided by psi is 0, 0, cosine will be 0, 1. If you put I just reversed the angles. Okay, you'll see that if you reverse the angle, you still have phi plus psi, so you'll still get the same thing, right? Because I'm just ensuring that phi plus psi is the same. So you have 0, 1, 0, 0, 0, 1, 1, 0, 0. You could also try something like this. Phi equals psi equals pi divided by 4. Still the sum is pi divided by 2. You'll still end up with so what it means is these three particular just test cases are three different ways in which the object has rotated, but the rotation matrix is just the same. Okay, so think of the so we know that if you do rotations, you will not end up with the same configuration. In fact, I'll show you a sort of animation which shows you that. But clearly that you end up with the same rotation. That is the inability of this representation to show different orientations once you choose one of those, that is in this case theta is pi divided by 2. Okay, so this is, we write it down as R or. So I'll show you an animation. Before I show you that, I'll just complete this. Since these give the same R matrix, we are unable to distinguish these three different rotations from each other. Okay. So this is the gimbal lock. That is the inability to represent certain configurations because the use of Euler angles. Oh. Okay, so the fix to this can be fixed using okay, so one way is the quaternions, which is the preferred method. There are other ways to do it. There's another axis added to the Euler angle, so fourth axis, which keeps track of this. We'll not get into this. It's not a very popular method. This one is more popular because quaternions are widely used by most numerical methods. So we'll use quaternions for representing orientation. So what happens is Euler angles are nice for visualization because we can rotate about 3 axes. Quaternions, as you'll see, don't have that kind of interpretation, visual interpretation. So there is another representation which helps you to visualize quaternions. I'll talk about that. So we'll always use Euler angles to show how things rotate. It's very easy. Of course, keeping in mind that certain configurations cannot be represented, but when we do the math behind the scenes, we'll always use quaternions. That's what the a package will use. I'll show you some code which will show you this loss of representation. The same example I showed you, the gimbal lock with just that block, how it loses ability to represent ability to show certain configurations. So here is another code I wrote. Okay, gimbal lock. I'll run this. It basically runs those 3 test cases. So you'll see 3 by 3. What's happening here is you start off with the same configuration. The first thing I do is rotate by 90 degrees. Okay, so all these 3 are rotated by 90 degrees. So no wonder they'll be the same. So now we are in the gimbal lock configuration. After this, if you want to do rotate about 90 degrees about the Z, so that was one of the cases, you end up with this configuration. If you do 90 degrees about X, you end up with this configuration, and then 45, 45 end up with this configuration. Okay, and that really doesn't make sense because those should not end up with those configurations. You can check it out. Right? So take this, for example, and then rotate about 90 degrees about what? Z. So Z is blue. This shouldn't give you this configuration. You rotate about Z, it should actually rotate the, oh, it should actually work. Sorry, that will work. This one is 90 degrees about X. Yeah, this one will not work, right? If you rotate about 90 degrees about X, which is this, you shouldn't end up with this. But the formula tells you that it is actually the same rotation, so it should be the same. So the way I got this figure is I used the formula, the rotation formula, but clearly that's wrong, right? This one shouldn't be that, and that one shouldn't be this. So you can check it out. This one is right. Yeah.
But it's because in the last one we should have before turn 90 degrees along X and then
40 or 45 about Z. Yeah. 45 about X, 45 about Z. But that if you take this and do 45 about X and Z, you'll not get this.
Yeah, but shouldn't we first from 0, 0, 0 rotate 45 around X, then 90 around?
No, the gimbal lock happens when you do first 90 degrees about Y. Otherwise, there's no gimbal lock. Because the axes become parallel. Once the axes become parallel, you're in trouble. You cannot do anything after that. So you need to do that. The second column is important. That is where the gimbal lock occurs. So think of it this way. You're flying a plane. You do 90-degree rotation. You are in gimbal lock. Now whatever you do is going to be meaningless.